Hi, I'm Kineshwari. I'm going to define feasibilities and sustainability studies. Feasibility studies are preliminary studies undertaken in very early stage of project. They tend to be carried out when a project is large or complex or there is doubt regarding the proposed development. Actually, there are a lot of proposed feasibility studies. I will mention here a few only. First of all, establish whether the project is viable. Second, help identify feasible options and assist in development of other project documentation such as business case, project execution plans and strategy brief. Last but not least, the likelihood that an environmental impact assessment will be required. Next is I'm going to define the sustainability development. Sustainable development aspect is that it demands new and innovative choice and way of thinking. Innovation in technology are challenging organizations to make new choice in their operation, product and activities that impact the earth and people as well as economies. Based on sustainability, there is a three aspects, which is environmental, economy and social. I will give some example in environmental, economy and social. First of all, environmental. Examples are resource conservations like recycle or heat energy and emission influence waste. Next is economy. Economy, they have examples of economy which is yield and feedstock price or process cost. Third is social. Examples are process conditions and chemical safety. Thank you.
Most industries are making new choices in operations, products, and activities that indirectly impact the earth, the people, and the economics related to the industrial process. The key indicators are detected based on environmental and economics as well as the social sustainability design in order to study the feasibility of each butadiene production process. As you can see here, there are three different routes, route A, route B and route C that is determined in order to process the butadiene. Route A is through steam cracking of paraffinic hydrocarbon or known as the ethylene co-product. As you can see, these two tables differentiate between the benefits to sustainability as well as the challenges that are faced against sustainability. For route A, there's only one benefit, whereby there's more challenges for the production in butadiene based on this route A. It only produces higher purity of product, but more impurities are obtained from root distillation of butadiene. It's more complicated and costly, and it makes use of toxic chemicals which will impact the environment, as well as it uses high temperature and it needs a variety of feedstock. As for route B, which is the catalytic dehydrogenation of N-butane and N-butane, also known as the Hauger process, it regenerates the energy cycle for heat, as well as it produces high purity of product in the recycled recovery. But as you can see, the challenges faced by this particular process is it uses high temperature, and there are carbon 1 to carbon 3 hydrocarbons and byproducts of hydrogen in this process, as well as coke formation, and it has lower yield, and also the cost is higher compared to the other routes. For route C, which is the oxidative dehydrogenation of N-butane, also known as oxide process, there's far more benefits compared to challenges. Like it uses less heat energy, it uses the safest feedstock, lower process costs, lower feedstock price, as well as higher conversion and selectivity, which goes in par with the key indicators. And it also uses The only disadvantage is that it needs high temperature and it has a little bit of undesired product. So based on these differences in comparisons of sustainability,
Hello, my name is Janatul Fatihah binti Izaham, and I'm going to present to you the initial process flow diagram known as PFD of oxidative dehydrogenation of butadiene productions. So as you can see, this process is using N-butene as a raw material with additional of oxygen, which convert it into butadiene and water. This reaction is exothermic reaction by using heterogeneous catalysts such as Fe, Zn, Mg, and Mn. So, as you can see from the figures, you can see steam, air, and N-butene are fed into the reactor, which contain heterogeneous catalysts, will pass through the boiler and the quench tower. At quench tower, we're gonna cool down the temperature of product to saturated level so that it won't evaporate large portion of scrubbing liquid in the scrubber. If it's happened in the scrubber, it will damage the scrubber. So next, the product from the scrubber will pass through the absorber, which absorb any fluids that we want, and the rest we will vent it out. So the fluid from the absorber will pass through the degasser. We have to remove the gas from the fluids, so otherwise the bubble will form at the stripper. So the gas from the degasser, the effluent gas that produced, will recycle back to the stream of compressor. The product from the degasser will pass to the stripper, which we strip the crude butadiene from other fluids, effluent fluids. These fluids will be recycled back to the absorber. So I think that's all for part A. Thank you.